So starting on the left-hand side, we've got hardware partitioning. There are some very, very strong benefits to hardware partitioning. One of the biggest ones is the excellent isolation. The servers that provide this hardware partitioning scheme are the T-series servers and the M-series servers. What this allows us to do is to isolate, we see here a hardware partition, isolate physical components, then install an operating environment on each of those hardware partitions. If we had an error that caused a failure here, it would have absolutely no reverse impact on the other running instances because there is a hardware partition there. So again, your T-series servers, your M-series servers provide this solution. Now there's some downsides to this as well. A lot of times they run on expensive proprietary hardware, and there's coarse-grained resources, meaning when I isolate or allocate a particular resource to an instance, I have to allocate that entire resource. So an entire CPU is being allocated. Well, what if that particular instance here only needs 30 or 40% of the CPU? So the coarse-grained resource can be a bit of a concern here. Not that we can't address it, but we at least need to be aware of it. And another benefit here, mixed operating systems. So they all are not running the exact same version of the OS. So that's hardware partitioning. OS, or operating system partitioning. Oracle Solaris and Oracle Linux zones is what we're looking at here. There's actually a isolation, if you will, or a partition, if you will, of the host OS. So I'm running Solaris 10 or 11 out here. I'm running Oracle Linux here. And what I'm doing is carving up an operating system partition. And then inside of the OS partition, there's a separate application, separate workloads that are running. But behind the scenes, we're actually running on a common host OS. So I don't have the ability of that mixed OS or versions. I cannot mix the OS or the patch levels. Now, each of these will appear to the outside world as separate instances. Separate host names, separate IP addresses, their own separate port ranges. So the outside world looking in, oh look, it's a separate box. But we as administrators need to know that I'm actually running on a common host OS. Now, it overcomes this coarse-grained resources here with fine-grained resources. I can allocate what is called a CPU share. So I can take a physical CPU and carve it up into smaller pieces and then give part of one CPU to one instance and then part of the same CPU to another instance if I need to. Does that make sense? So, T-Series, M-Series, Solaris, and Oracle Linux. You can dovetail these. So if I had a T-Series or an M-Series server using either logical domains, which is now called OVM for Spark, okay, or I'm using what's called DSDs, dynamic system domains. Now once I've got that OS running up here, if I've got Solaris running up here, well, guess what I could do on that Solaris instance? I could carve it up so I could have both hardware and software partitioning if I need to. Does that make sense? All right. Continuing then, host-based hypervisor. Oracle solution here is VirtualBox. You can download VirtualBox at no charge. I use it on all of my laptops. I've got Solaris 10 running on it, Solaris 11 running on it. I've got a couple of different variants of Oracle Linux. By the way, my laptop is a Mac OS X laptop. Okay, it works on Mac. Sure does. It works on Windows. Sure does. Works on Windows. Sure does. Works on Solaris. You're actually running them right here. There's actually Solaris is installed as the operating environment on your classroom workstations. Inside of it, we've downloaded VirtualBox and I'm running Microsoft Windows inside of Solaris. Okay, it's free. That's the good side. Now, obviously, there's some downsides. Notice here that we've got two OSs. So in my example, I've got Mac OS X running here, and then Solaris running here, and Oracle Linux running there. So having to transverse through two different operating environments, it is in fact slower. Okay, and then our final solution, and why we are in class for these 3 days, the bare metal hypervisor. This is OVM for x86. So we have here is a bare metal install. So unlike this solution, there is not already a host OS installed. The hard drives could be wiped. Part of doing that OVS install is going to install a modified Oracle Linux instance with the Xen hypervisor. There's our hypervisor here. From it, we're going to create virtual machines using a subset of these resources. We'll allocate these resources through our Oracle Virtual Machine Manager. We'll tell them how many CPUs, how much memory, as an example, when I build that VM. We'll then deploy that guest VM on one of the physical servers in our pool. It will then, through the hypervisor, communicate and gain access to the resources that we allocate. So this is, again, the solution that we're using in this particular class. So excellent isolation, affordable hardware, fine-grained resources, and I can mix the operating systems and the versions. Any questions?